Exponential functions have a lot of real-world application in area of finance or science. So in this video, we're gonna look into those real-world application of exponential function. So you can model exponential growth or decay with this function formula. So this is basically exponential function. We have a 1 plus r is basically b, our base, and t, which is exponent. A represents the initial amount of or any kind of initial number to begin with. And 1 plus r means the rate of growth if r is positive, or if r is negative, it would mean rate of decay. And t just represents the number of time period. For growth or decay to be exponential, we have one condition. The quantity changes by a fixed percentage. That is, if a quantity change increases or decreases by a fixed number but not a fixed percentage, it wouldn't be an exponential, it would be a linear. So we're going to talk about that a little more in detail later. But for now, just remember that it should have fixed percentage to be an exponential form. So let's look into some example. We have 4 situations here and 4 different exponential functions, and then we're gonna just match each situation with the correct exponential function. So the first example, say you buy 50 mice. Every month the population increases by 15%. So the r, the rate of growth, would be the 15%, which is 0.15. That would be our r. So 1 plus r to the power of t, and the initial amount would be, in this case, you begin with 50 mice, so it will be 50. So this would be the function that represents that situation. That is, if you plug in a number here, maybe like 1, and then you calculate that number, that would mean the number of mice after 1 month. If you plug in 2, then you can get the number of mouse after 2 months. So that's, if I simplify that a little bit, that would be 50 times 1.15 to the t, or x or m. This can be any letter. So if you look at this function, this is exactly the same thing as that function, except we just, this one is using different variable. So we can match this too. If you look at the second example, you have 1 pound of dog food. Your dog eats a quarter of it. The next day, each day afterward, the dog eats a quarter of what's left. That's a little bit odd because the dog, I don't know how that works, but anyway, the dog only eats a quarter of whatever that's there. So a quarter is 1 over 4, which is 25%. If the dog eats a quarter of it, whatever remains will be decreased. So that would be minus 25%, which is the decay, rate of decay. So our r would be negative 1 over 2.5. We just convert the percentage to the decimal. So 1 plus r would be 1 minus 1 over 2.5 to the x power, and then we have initial amount, which is 1 pound. So I'll just write 1 here. So if I simplify this a little bit, I will get 1 times 1 minus 0.25 would be 0.75 to the x power. So this will be the function. So we have right here, we can match this too. Okay, third one, you get a job paying $8 per hour. Every year, the salary increases by 5%, exactly 5%. It's a fixed percentage to keep up with the cost of living. That makes sense. So the initial amount will be 8, 1 plus r. R will be plus because it increases. If the salary decreases each year, it would be minus. So increases by 5%, so it will be 0.05 to the x power. So that would be 8 times 1.05 to the x power. So this function gives you the amount of salary you receive after x years. So if I plug in 2, then you can get the amount of salary you can get after 2 years. So that function matches with this one. Last one. Your saving account holds $300 currently. For all accounts under $1,000, the bank charges a fee of 2% per month drawn from the account. So you currently have $300, that's the initial amount, and since you have less than 1,000, the bank charges 2% of your account each month. So since they charges 2%, your balance would decrease. So our rate of decay would be minus 2%, which is minus 0.02. So that 300 is our initial amount, A, and then we have 1 plus R, which is 1 minus 0.02 to the x power. X means the number of months because they charge that per month. And this function would give you the balance of your account because you get 2% off every month. So this would match with the first function right here. Or you can just rewrite and simplify that as that's 99.98 to the x power. That's the same function.